Hello, everyone. Good morning, good afternoon, good evening from wherever you have joined. Welcome to the Chaos Engineering Monthly Meetup. Moving forward, we will be looking at the agenda of this meeting. Just a second. Yes. Um, so for the introduction, we have Dave from Harness. He's the Senior Director of Communication Relations. Welcome, Dave. Post that, we will be having an introductory session of Chaos Engineering with Litmus Skills by Saranya, and we'll be looking at a demo by Orco, which will be about Pod, CPU, Hawk, and both of them are senior software engineers at Harness. Post that, you guys can post in your questions if you have any questions for any of our speakers. So yes, without any further delay. Yeah, the stage is all yours, Dave.
Great. Thank you, Sarita. Hi, everyone. I just wanted to take a moment to welcome the Chaos Native team to Harness and to share our excitement for having to now be a part of this project and to have the team that helped make this project a reality now joining Harness. And as many of you know, that Harness started off as a continuous delivery company. And what we did is we set out to focus on solving that problem so that companies could reliably count on an automatic continuous delivery. And we've done that, and we've been very successful at it. But as you all know, that's just one piece of the platform or pipeline that you would need in order to successfully deploy your applications. And chaos engineering is a very exciting component of that. Just by my own introduction, I've run events and communities for many, many years. And one of the first times I ever heard about chaos engineering was right out of Netflix when they were promoting Chaos Monkey, and Adrian Cockcroft, who was one of the lead promoters of chaos engineering or Chaos Monkey back then, actually gave one of his very first talks at one of my meetups, just like this, but back in the days when we were doing them in person here in Mountain View. And it was just an exciting technology, something that you just didn't expect. It was one of those, looking back at it, you go, well, of course that makes so much sense, but at the time it just seems so crazy to just eliminate services. So it caught a lot of attention then, and now it's really wonderful to see that it's not just something that's exciting to talk about, but it's a lot of people are deploying it and using it to successfully improve their reliability in production. So yeah, it's just wonderful to see it come all this way, and I'm really excited to have Chaos Native team join Harness. And really my main purpose here is to let you know that not only are Sarita and Prithvi and the rest of the team, Ajesh and going to continue to do what they're doing, and nothing's going to change, but we hope to add additional resources and promotion and try to work with the Cloud Native Foundation even further to push this open source project and the technology further. One thing I would like to do is invite you. We have a conference that we're organizing in September, on September 14th. It is an in-person conference right now, although it looks like we're going to add an online component to that. So folks from who are not in the San Francisco Bay Area can participate. But pay attention to that, because what we're going to be talking about there is, one of the components will be chaos engineering, but also other technologies and innovations that are helping companies deploy more reliably. And I would love to have you be a part of that in some way. And I will share further information about that maybe at a future time. But if keep an eye on that for September 14th. Other than that, that's really all I have to say today. And just again, welcome, and or let's say I should say thank you for welcoming me into this meetup, and I look forward to participating again in the future. Thank you.
Thank you, Dave, for that introduction. Saranya?
Yeah, sure. So hey everybody, this is Saranya, and I work at Harness as Senior Software Engineer and also one of the contributors to Litmus Skills. So let me share my screen. I hope my screen is visible.
Yes, Saranya, it's visible.
Yeah. So today I'll be talking about like a brief introduction to chaos engineering and how it can be done with Litmus Chaos. And this will be our agenda. Like first of all, I'll be talking about chaos engineering, how and why is it required. Then I'll be giving a brief introduction to Litmus Chaos, talk about its architecture and its core components and features. So let's get started. So to start off with, first of all, we should know what is resilience. So resilience is basically a system's ability to sustain a fault and bring itself back. So let's say you inject a fault in your application, it goes down, and the application should be resilient enough to bring itself back up. And yeah, so these are some of the examples you can see. First of all, like let's say your pod gets evicted from the node, and it's like, what is its state? Is it healthy or not? Does it bring itself back up? If it does, then the application is resilient. And like that period from going down and bringing itself back, that is the resilience. So similar is the case with node and memory leak as well. Then yeah, let's talk about downtimes. Downtimes are expensive, like especially in terms of cost management. You can see these are some of the examples of how it had happened back. And I have added some very recent examples of outages and downtimes. Like you must be aware of the Atlassian outage that just took place this month, and Facebook outage. So here you can see that it's not just in it downtimes affects us not just in terms of money but also in terms of other aspects as well. So let me talk about them. Yeah, so that this is the actual cost of downtimes. So they affect not just in terms of money but also in terms of loss of like customer confidence, damage to brand integrity, diversion of resources, then loss of employee morale, confidence. So considering these cases, this aspect is also as important as money. And considering all these, we should always avoid downtimes at any cost. And one way to do this is entering into the practice of chaos engineering. So chaos engineering is the process of testing an application like a distributed computing system by injecting chaos, like injecting fault intentionally. So the goal here is to identify the weaknesses in your system through controlled experiments, and like in order to ensure that your application behaves fine in and can withstand unexpected circumstances. And chaos engineering can be done at any stage of your development. So earlier we used to test our application in dev, but nowadays like it is equally important to test our application in ops side as well. Because like as developers we do a lot of tests like integration testing, E2E testing, etc. And we become confident about our application. But what if the fault occurs in the ops side? What if the pod goes down, or what if there's a network loss? So these kind of situations, E2 test won't be able to identify. So it becomes important for the SRE personas or any individual to practice, like to test their application in production or like in the ops environment. And with Litmus Chaos, you do have this flexibility. Like there are a variety of experiments available, and you do have this flexibility to practice like chaos engineering in both dev and ops side. Then how it is done. So in like basic steps, step one would be to, first of all, you need to identify the steady state conditions. Steady state conditions means like it is the desired the desired behavior of the system in a given scenario when the application is healthy. So you first identify the condition, then you inject or introduce a fault in your application, then you check if the steady state conditions are met or not. If yes, then your application is resilient in that scenario. And if no, you just identified the weakness and you can go ahead and fix it. And if something similar happens in productions, you are already covered. Then I would like to talk about the cloud native chaos engineering and how it can be done effectively. So the cloud native definition, like the definition includes some principles, some mandatory principles such as like having declarative config, being scalable, flexible, and supporting cross cloud. So these are some of the principles that we have been advocating in the like past few years. And yeah, so uh, like I'm moving on to the points that are being mentioned, the principles of cloud native chaos engineering. So the cloud native communities and technologies have been revolving around open source, and these chaos engineering frameworks being open source have this like get this benefit of building strong communities and make themselves better by becoming like become rugged and feature rich. And the chaos experiments that will be used should be very simple to use, flexible, highly tunable, and with a very little chance of false, little or no chance actually I would say, of false negatives and false positives. Then coming on to the third point, that is open API lifecycle management. So with more and more people coming into like involving in chaos engineering, more and more changes occur, that too very frequently. And with the like there's a high possibility that the requirements get altered at the last moment. So chaos engineering framework should enable the workflow, like it's a workflow management very easily, and that should be done in Kubernetes way. Then then next point is like GitOps. Then as I start practicing chaos engineering and start identifying simpler issues and fixing them, more and more chaos scenarios come into picture, and gradually it becomes very large and comprehensive. So these scenarios need to be automated and triggered when there's a change in either the target application or the chaos experiments. So tools around GitOps can be a way to achieve it. Then lastly, we have the open observability. Open observability is also one of the mandatory features, like principles of CNC, and introducing chaos engineering should not require and like new observability system. So the existing observability system should be able to fit in perfectly. So for this, the chaos metrics that are being like should be from the chaos metrics from the systems where the chaos is induced need to be exported into the existing observability DB. So with that, I would like to introduce LitmusChaos, which is an open source cloud native chaos engineering framework. And it does support, like it has the cross cloud support, which means, let's say if you install, like let's say we install Litmus in AWS, and the target application, the application where we'll be injecting chaos, it's sitting in any other cloud provider such as GCP or Azure. So Litmus would be able to inject chaos in that application. So there's a cross cloud support, so that is being supported. And then it is now a CNCF incubating project with adoption across several organizations. And these are some of the current stats we have around now. It is like 51, 52 experiments with around 886K plus runs and more than 2.5K GitHub stars. Then in DevOps, where it can be used in CI pipelines or any long running tests, or you can create your own custom GitHub hook. Let's say, for example, PR, where a certain action can trigger the injection of chaos in the application. Like let's say when the PR is raised, where then the GitHub action can trigger the injection of chaos. So similarly, it can also be used in staging, pre-production, and production environment as well. And so let's talk about the architecture, the complete architecture of LitmusChaos. Starting off from the left, we have the persona, that is SREs, developers, QA, or any individual which is practicing chaos engineering. Then moving on to the, like in this case, we would be using WordPress as the target application, and which is trying to connect MySQL DB in order to do a transaction. And here we'll be using pod network latency to induce chaos. And so this is the hypothesis, and the steady state condition would be the application is working completely fine despite of the network latency, and is able to do the transaction. Then coming to the kiosk control plane, here we have the kiosk center, which is the like main entity, the GUI, which manages all the kiosk related activities. Yeah, and it has the three major components. First one is the auth server, which handles the authentication and multi-tenancy and user onboarding. Then there's the GraphQL server, which exposes certain APIs, and it has a WebSocket connection with the subscriber to do the like workflow related to the actual chaos injection and all. Then there's the MongoDB, which stores data that being generated through the servers. Then coming on to the rightmost side, we have the chaos execution plane. So chaos execution plane is where the actual chaos activity happens. So here we have the chaos agent being installed. So let's say you want to target an application sitting on GCP cluster, and so you need to install the chaos agent in that cluster, and it can be installed in two scopes. First one is the cluster wide scope. So let's say if you want to target all the namespaces in that particular cluster, you can install it in cluster wide scope. Or if you want to target some particular namespace, then you can install it in namespace scope. Then we are having Orgo workflows. So for that, Orgo workflow controller is there, and this event tracker is also there for handling and managing GitOps. And chaos exporter, like Litmus just provide monitoring, so we have the chaos exporter like monitoring using Prometheus. Then we are using like, let me talk about the CRDs being used. So we have Chaos Experiment CR and Chaos Engine CR. So Chaos Experiment CR is the one which, like, it is basically the template of the complete entire workflow, entire experiment. In that, like in this case, we have the pod network latency experiment. So it has the entire blueprint of the experiment, and all the metadata when it is injected, like when it is when it is scheduled, when it is running, all the metadata, all the data related to that experiment is being pulled from a place called Chaos Hub, which I'll be like showing you in a while. And there's the Chaos Engine CR, where you can add the tunables, such as like let's say you can like if you want to change the chaos duration, you can use the, like you can do this with chaos engine CR. So you can add all the tunables, all these things by chaos engine CR. Then we have the chaos exporter, which keeps a watch and does all kinds of validations, such as the chaos agent is like present or not in that cluster, or the tunables that you provided are valid or not. So all these validations are done with the chaos exporter. Chaos operator. Then with Litmus, you can target non-Kubernetes, Kubernetes, or bare metals, VMs, etc. So let me show you the Chaos Hub. Yeah. So this is the Chaos Hub I was talking about. It contains all the experiments. It has node level experiments, pod level experiments, some infrared chaos as well. If you click on any of the experiments, you can see all the, like you can see your demo and all the details, the YAML required YAML files are back and all. You can use them from here as well. So this is the Chaos Hub I was talking about. Then yeah, let's so let's talk about the core components of LitmusChaos. Litmus at its core has two components, Chaos Center and Chaos Agent. So Chaos Center, as I've already talked about, it is the main entity, the main management center, single source of truth, I would say, to manage all the chaos related activities, such as creation of workflows, scheduling them, multi-tenancy, all these activities are being managed from Chaos Center. And we have the Chaos agent that I've also talked about. It is nothing but the target agent, the target cluster. So let's say your application, your Litmus is installed in cluster A, and your application is in cluster B. You would the Chaos agent needs to be installed in cluster B, and it can be done in namespace or cluster wide scope, as I have mentioned. And let me show that also. So this is the Chaos Center I have talked, I just talked. So I am running my Chaos Center on Minikube, and I have logged in as admin. And by default, admin project gets created. And yeah, so this is where you can find all the agents. So after successful onboarding of the user, a self agent gets created, gets connected in this in the same cluster where the Litmus is installed. And you can also enable connect external agents, number of external agent by using Litmus CTL, and following the required steps. You can connect any number of external agents as well. So yeah, that's that. And so with that, I would like to talk about the features provided by Litmus, and especially Chaos Center. So first of all, we have the Chaos workflows. Workflows, these are basically the Orgo workflows, which we can add several we can club several experiments, Chaos experiments, and in any fashion, in any order, maybe sequentially or parallelly. You can create such many workflows, and it can be created, all the workflows can be created, there are multiple options. Let's say if you have a certain workflow in your mind, you can create your own template, upload it, and use it, and also save it for future. And then you can also create your own custom workflows from scratch by, you can either use the default Chaos hub that I just showed, or you can use your own private or public Chaos hub as well. You can get the experiments, add the experiments from the hubs. And lastly, we do have some pre-created YAMLs as well, where predefined, where the application also gets installed along with the experiments. So you can also use that. Then third point, control, as I've already mentioned, you can club the experiments to create a workflow in any fashion, maybe parallelly or sequentially, so in any order. And after the creation is complete, you can schedule the workflows in singular or in recurring workflows. Like the recurring is the cron workflows, and you have the ability to attach priority to each of the Chaos experiments. Let's say in a workflow, you can add priority, add weights to each of the experiments. So higher is the value of weight being added to each experiment, higher is its priority. So you have that control as well. Then moving on to the workflow management, first of all, we have GitOps. I would be talking about it a bit later. Then Litmus also allows you to add your own image, add your own custom image from your own image server, which can be either private or public. Then you can also measure and analyze the resilience score of each workflow after the Chaos injection is done, workflow is complete. You can analyze them. So we do have a concept of probes, which are the pluggable checks you can add along with the Chaos injection. So let's say if you want to add a particular check in your workflow, you can add it via probes, and after post the workflow, after the workflow is complete, you can check if that particular probe or that particular check is passed or not. So that can be done using the probes. And currently we have number of Litmus provides a number of probes such as CMD probe, KTS probe, PromQL probe, etc. Then with the latest Litmus 2.0, you can also it supports multi-tenancy, which means you can create your own project, create your own team, add other individuals as well. You can invite other users, and yeah, this brings us to the there's a fine-grained role-based access control also. So let's say in project level, there are 3 roles, that is the owner, editor, and viewer. So an individual who creates the team, that creates the project, is the owner of the project, and it has he or she has all the access, and he or she can like invite other individuals as editor or viewer. So an editor, like if the individual joins the project as editor, he or she can create or manage the schedule or manage the workflows, but as viewer you won't be able to schedule them or like manage them, but you can analyze it, so like from the analytics section, or view it, all these statistics and all you can view. And on portal level we have like on user level you have we have two other roles as well, that is the admin and user. Admin is the one which has the highest privilege. It gets created when Litmus is installed and admin logs in, and admin is the one who creates other users. Then there's authentication, like without authentication, like you have the security and smooth onboarding, and you also get the opportunity, like you also get the you get to choose to enable like OAuth or not. You can like OAuth can be done like with GitHub or Google. So that's there. And scope support, as I have mentioned, you can install the agents in cluster scope or namespace scopes. So yeah, that's that. And moving on to the monitoring and observability, you can connect your own data source and monitor your workflows. Then there's a like in the analytics section, you can visualize the runs, workflow status, like workflow runs, schedules, get all the statistics. And then you can also compare two or more workflows. And in case you do not like the interleaved dashboard, you can upload your own dashboard. And there are also dashboards available in the community. You can download them and upload the same. You can also tune them, edit the queries and tune the dashboards from scratch, from as per your own requirement. And then lastly, you can, like Litmus also provides a real-time monitor. You can also monitor the chaos in real time as well. Then GitOps, that this is the section I was all like previously talking about. So Litmus also integrates with GitOps, that like integrates with any Git-based HCM, that is source control manager, to provide a single source of truth. That means it like provided that GitOps is enabled, and after once enabled, it kind of switches off Mongo as the DB, and the Git source would be acting as the single source of truth. So, and these are like this is done bidirectionally, like it is synchronized bidirectionally. That means if any change occur to either the workflows in Chaos Center or in Git, it will trigger the rerun of the workflow. So yeah, that can be handled, that can be done. And then moving to event tracker. So Litmus also supports event triggered chaos injection. That means there's a event trackers microservice which automatically launches subscribed workflows. Like let's say if some any change happened to your application, like such as upgrade, any upgrade happens, so in that case, it will automatically trigger the injection of chaos. So yeah, that's that. And lastly, Litmus also supports non-Kubernetes chaos. That means like you can now attack any bare metals, VMs, or any machine via like now agent is there. You can use that, or any infra resources as well. So with that, I would like to conclude, and Orku would be giving a demo of how you can also inject chaos. So yeah, thank you.
Thanks, Arna. That was a lovely presentation. I'll take over and try to give a demo for pod CPU hog experiment. Share my screen. So just a formal introduction. My name is Orko Mukherjee. In short, you can call me Orko. I will try to provide a demo for this pod CPU experiment. And yeah, I'm also a contributor in Litmus. I've been working in Litmus for almost like 2 years now. Let's hope the demo goes perfectly as planned. So I have a application. I have my Chaos Center installed in an EKS cluster, right? And I have also this SockSop application installed, where I will be. It's a common microservice that is being used for testing of this distributed systems. So I will be applying the Chaos Engineering on this catalog pod, right? So I have it monitored here. So I'm monitoring the CPU load of this catalog pod, and also I'm monitoring the network latency. Now, before I jump into the experiment, I also want to simulate a user generated load and see how it looks. So you can compare it with the load generated by the chaos experiment. So I am using Fortio load gen here. So let me apply this thing, and we will try to simulate user load for 60 seconds. Just wait while this is applied. Yeah, so we should see change in the graph for 60 seconds that will simulate our user load. For now, you can see the CPU usage is very low. It's like these are CPU cores in the y-axis. So it's 0.003 to like 0.0. It's not even crossing 0.004. So let's see. You can see the spike here. This is your load gen trying to consume some random amount of requests is sending to this catalog pod, and is trying to simulate user request to this page basically. Now let's also while that is going on, we can also explore this Chaos Center. So I have my Chaos Center also installed in the same EKS cluster. So you can connect an external agent but by default, when you apply the Chaos Center, a self agent, meaning the same cluster is captured as an agent. So this is automatically created for you, and you can do chaos testing on the same cluster where you have applied the Litmus Chaos manifest basically. So wherever your control plane is, you can also do the chaos there. But you can connect any external agent through a CLI we have called Litmus ATL. So in my case, both the application and the Chaos Center is installed in the same cluster. So for me, self agent will do. And I will try to run some. I've already run some previously. I will try to run pod CPU hub experiment. Meanwhile, we can look at this load gen. You see a new pod in the red. Fortio has come up and is trying to simulate user load. We can also see the network latency will not have a huge impact because we have 2 cores available for this, and it's nowhere near being utilized. It's only 0.02. So you don't have a spike in the network latency too much, that is. So after this, we can also go through the experiment and see how different it is from normal generated user load. And we can also have this user load on top of an experiment to see if there is some effect or not. So you can set this up using your existing monitoring setups, using Grafana, Prometheus, whatever you're using. We have guides for everything LitmusChaos repository. In the monitoring section, you will find all these things. There's a good README you can go through if you want to set this up and run this similar kind of experiments on your own. And you have already dashboards available, Grafana dashboards and everything. We have SockShop. You can go through them on your time, and we have guides for everything. So as you can see, these things going up, the pod started acting from here, and CPU load has increased quite a bit, but not nearly enough. Now we'll also, meanwhile, we can go through the experiment. Will not run it as of yet. We can go through and prep the experiment. So in your Chaos Center, you can click on schedule a workflow that will go through this workflow wizard where you can set your experiment. So the first step is you can select your self agent. So or any agent you have connected. For me, it's the self agent that is automatically created for me when I install the Chaos Center. So I select this and I click on next. I have a couple of options here while creating the workflow. I can create it from an existing predefined workflows that I have. So I have Shop and all those workflows here. I can do it from a template that I've saved. So any existing workflow, say I have a schedule, right? I have worked hard and made this thing. I can save those as a template, basically. So I can save them as a template. So that will be available to me there. So if I save this, and now I should try to schedule a workflow, I should have this available as well. See, I have this template. The third option is you can create your experiment from your hub, which Sarnya was talking about. So I have the public hub by default. You can see all your hubs here. So here you will have, if you have a private hub that is your own clone repository, which has some private experiments, you can have a hub connected as well. We're using the public hub as is. Let's check this. Meanwhile, yeah, see, this is the load gen has finished and is the CPU is going down again, right? So coming back to here, we have our hubs we can connect. So we will go with the third option, and the fourth option is you can import your custom YAML if you want to. That's also a possibility. We will go with the third option. We'll create an experiment from scratch and tune it according to our liking. So you click on next. We can name this. Let's name it right. You can give a description. Right. And you have the first step is always your installation of your chaos experiments, and you can add experiments from this hub. So the hub opens up and you can choose an experiment if you want to. So I have there's multiple experiments you can choose from. I will choose from the generic category, and you have your pod CPU hog at the top here. Pod CPU hog, generic / pod CPU hog. I will choose this one. You can search it if you're not able to find it. Pod CPU should be available, right? Yeah, pod CPU hog is available here. So I add this experiment, a new step gets added here as pod CPU hog. Let me also meanwhile prep this, delete the existing job so that I can run it again while the chaos experiment is going on. Keep it prepped here. Yeah, now I have this step added. I can see the name of my experiment, the namespace and everything. So this is not the application I'm targeting. I'm not targeting an engineer's application. So let's edit this. So let this remain the same, the name and everything. I don't want to change that. But this one, I want to have the sock shop namespace. I have the application installed in this namespace. It won't be the default one. And my app label will be the catalog. So as I said, I am targeting this page specifically. So you have your multiple pages, your cards and everything. So I'm targeting the catalog page, this one. So I have chose the catalog. So this label will be essentially find the pod named catalog, and it will target this chaos on it. Right. Next, you have some probe if you want to check some do some sanity checks after the experiment or something. You want some verification to be done. We have multiple probes called HTTP probe. You can call an API and check if you are getting the correct responses 200 or not, or something like that. You can attach probes. There's command probe. After experiment, you can run a command to verify your experiment if you want to. For in our case, we don't need to. We are just checking the CPU load, so we don't need to run any commands. So we'll skip this one. And this is your experiment tunables. So let's make the chaos duration as 2 minutes, 120 seconds. I'm targeting max CPU core, so it's 2. I know it's 2 CPU cores, and I'm and I will affecting all the pods. So if I have multiple replicas of this pod, I will affect all of them. So I am putting 100% as the pod effect. So there are more variables. If you want to change your container runtime from Docker to Cryo or something like that, you need to also change this one. But these are only the default ones that are loaded. You can access more experiment tunables in the documentation. So there are these many experiment tunables for this pod CPU hog experiment. There are more experiments and have different tunables and everything. But for this demo, I need these variables, the total chaos duration of 2 minutes, the CPU cores, and the number of pods affected, percentage of pod affected. So if you want to maybe use some of these, suppose stress image or something like that, it is not present here, you can add it as a key and value pair. That is also possible. Now, this is my configuration that I want to do here. I click on finish. And this revert will delete the experiment pods after the completion of the chaos. I don't want it right now. So I will disable this because I want to show the logs after the experiment and everything. So I want the pod to be there so that I can script the logs. Now we can click on next, and this is your experiment, and you can put assign some weight to it. Basically, if you have multiple experiments, some experiments might be more valuable to you for your application resiliency, some maybe not. So you can essentially prioritize or deprioritize them. So this has no effect on the actual chaos run. Like deprioritizing them will not run it for less duration or anything. It's just for your monitoring, you can put that this experiment is not that important, and based on that you can calculate your resiliency score. So this is basically for calculating the resiliency score. For me, I have only one experiment. I will put it at max priority and click on next. And you can choose a schedule if you want to click. So you can schedule it at every hour or every day or every week, month, or something like that. But I want to schedule it right now because I'm showing the demo. And the final step is you can verify and commit this, and this will run the workflow. But before I do, let's make sure this, okay. I can expand it to maybe 15 minutes so that I can show the load gen as well. Here was the load gen, so I can compare it. Let's do the same for here. Right. So yeah, you can view your YAML here, the experiment YAML. So this is a workflow YAML that will be applied to your to create all the resources and have the experiment there. So we can see the environment variables here for the pod CPU. The experiment is here. This experiment name, pod CPU hog, and this is the spec. So we have the environment variables, total chaos duration, CPU cores, percentage affected, container runtime, and everything. So if you have added some more environment variables, that would come up. If you have added some probes, that will be shown here. So all these things you can see are, you can also edit the YAML manually in a previous step. So let me go back and show that as well. You want to edit the YAML here, you can do this. For me, I don't have the requirement, so I will just not. Let's double check everything. Yep. Okay. Yeah, so I think we can start the experiment. Let's click on finish, and we can go to the workflow. So you can see here the workflow is running. Soon it will install the experiments, and you will see some things. You can go to the table view if you fancy that. This looks cooler to me, so I'll stay here. So installing experiments, you will see some effect here soon enough when the experiment comes up. See already pod CPU hog. You can see here the pink one line is showing up. Let's see how it affects the experiment. Network spike is just normal for now. You won't see immediate spike as of now in the network latency. We can also run probably load gen halfway in if you want. So that will run for 60 seconds, half the duration of the chaos. So we can test real user load on top when the CPU is at its peak or something. We can do that. So all we have to do is wait. The chaos is running now. It is installed and it's running now. So we have to wait and see how it performs. So all new pods coming up will be shown here. If you want to unclutter that, you can just click on here and okay. There's a clear distinction. This was a load gen when we simulated user load, and it's rising now for our this is the CPU consumption has increased when we have run chaos. So there's a significant difference you can see. So it's stressing our CPU right now. It's at 0.5. Let's see if it goes to near about 2 core. So this should effectively increase even further. Meanwhile, we can also let's hold on to this load gen. We'll simulate the loader a bit later. You can see the time duration here. This will go on for almost 2 minutes, and we can see the effect of this. So it has reached almost 1 core now. It will not go exactly 2 because that's not. It won't go exactly 2, but it'll go near about like 1.7, I guess, something like that. So we are at 1.4. We are near about there. Let's also apply some real user load on top of this so that we can stress this even more. Meanwhile, here we don't see much of a change right now. Still being able to handle the latency is not that much as of now. Right, so see it's flattening out. You will see some randomness on top because we have also applied load gen. So that will create some random load and requests on top of this. So latency is increasing a bit, but it can still handle. It's not much. It can still handle latency. Meanwhile, you can see the experiment has actually finished. We can look at the logs here as well. The experiment logs are available. The kiosk result is available. So what happened to the experiments, you can see here, right? So probe success percentage was 100. So that means it's passed. The verdict was passed. The experiment completed. So our experiment passed essentially. So even if you experiment pass and fail doesn't depend on your outcome, your system might fail, but that doesn't mean experiment will fail itself. So experiment has passed means it has successfully run. And if you have some probe results that say this is the condition that the experiment should fail, then the verdict can change to fail, basically. So successfully, it has run it spun up a helper pod that actually did the CPU hogging. So that helper pod status is there. It was running for all this duration and it was succeeded after 2 minutes. And it has deleted the helper pod after doing that. So chaos has been successfully injected. We can also see at the top, it was choosing the application based on the labels. Yeah, so we can see we gave the label as catalog, so it took up the right pod and applied chaos to it. So it took up the right pod here. Let's look at the graphs once more. So this is now flattening out, the chaos is ended. So this was a duration. Yeah, we don't see much change. It increased to 10 milliseconds, the response, but it's going lower again. So now it will go randomly somewhere. But yeah, our load gen has also stopped. It should have been finished after 60 seconds. So this was the effect of chaos on your system. Soon after, it will resume back to its normal state of like 0 point something. It went nearly to 1.75 or something. CPU usage testing is almost testing its limit. So there's still some bandwidth left. So that's why the application is performing. But if you have real user load, which is like in tens of millions, then this will really affect your performance and you will be able to see the impact on your users. So based on this based on this results and observing it, you can make decisions to edit, change your application. Basically, you can handle load in a certain way. You can increase the replicas so that this doesn't happen. You can allocate more resources to your suppose this catalog is getting choked really easily. You can add more replicas to it. You can add more resources, allocate more CPU to it. So the decision is basically based on the results you are seeing and what you want to achieve and how important that functionality is to your application. The decision has a lot of factor based on the particular scenario you are in. But regardless, the chaos is giving you a simulation of how actual load will, how your application will perform in actual load. In a very stressed condition, how will it perform? So you can monitor your stress here and make decisions according to that. So that was the demo. If you have any questions, we can take it up. And that's it. Stop my screen sharing.
Thank you, Orko, for the demo. I hope our participants gained a lot of insights from that. And we do have a few questions in the chat box, if you can give your version of the answers.
Okay. Two CPU cores means what? Two CPU cores means the deployment where I deployed the application SockSwap, it was allocated to CPU cores. I don't know what you mean by the questions like CPU cores or CPU cores. So it was given a maximum CPU core of 2 and I consumed all its resources. Basically, I choked the CPU as much as possible with this experiment. Vedant has answered the question, number of cores we want to consume. Yeah. Chaos Engineering. This is also answered. Does it have an API to code and test? You means the yeah, our APIs are public. So LitmusChaos has its API public. You can check them out if you want to inject chaos through APIs. That's also possible. Imports. We'll have most of the resources in Slack, so you can join there and we'll share more resources there. Yes, automation is essentially possible. We can automate through the APIs itself. So yeah, automation is possible. And if you want to automate certain checks after your chaos has been run, then you have probes. You can run an HTTP command if you want to, or a command probe can run any command in your shell, and you can verify that accordingly. So that kind of automation is also there from the chaos in the chaos application side. So our APIs are GraphQL based. So you need and apart from the authentication, which is a REST, other APIs are GraphQL based. You can use them. Okay, can you explain what happened behind the scenes? Okay, so what happened was this chaos, this pod, the experiment basically launched a helper pod that actually helped create the stress on your system. So so we are injecting the fault with the help of a helper pod. There's another version of this called pod CPU of exec, which it execs into your system and injects the load there. So that is also another version we have. How to contribute to Litmus? Yeah, you can. We have a contributing.md Ajish has shared, so you can look into it. We are open to contributions. We're an open source project after all. We welcome any contribution you can make. Definitely. Yeah, Karthik has given a good explanation on the helper pod. And what it does basically. Sure. Any questions you can shoot up. We can also take them in chat, or I can answer directly.
All right. So if we do not have any further questions, I think we are good to go. And thank you for joining in this meetup with us. I hope you join the next meetup as well.
Yeah.
And yes.
Yeah, sorry. Before we wind up, probably the team members or the new members on this call can introduce yourself, so that way we can get introduced to each other.
Yes, definitely. So we have Krunal. Krunal, would you mind unmuting and introducing yourself? We have Venkat as well, and Girish.
Nice to see new folks here. Welcome everyone.
Yeah, thank you all. Krunal here. Yeah.
Hi, Krunal. You are very interactive. Nice to see.
Yeah.
Make sure you join our Slack channel for further communication. Thank you, Krunal. I think we can wrap it up, Ajish.
Yeah, sure.
Yes, thank you for joining in. See you in the next meetup. Have a good day.
Thank you all.
Thank you.
Have a good day.